Welcome to Physics for Everyone, Energy and Momentum. In this video, we will explore the fundamental concepts of work, power, energy, momentum, and collisions, revealing the physics that governs our everyday lives. We will cover 6 essential concepts, starting with the basics of work and energy, then moving into power, momentum, and impulse. We will examine the conservation laws, real-world collisions, and everyday applications. Section 1 covers work and energy. Work occurs when a force moves an object, defined by the equation, work equals force times distance, measured in joules. Energy is the ability to do work, classified as kinetic energy for motion and potential energy for stored energy. There are 2 main types of energy. Potential energy is stored energy, calculated as mass times gravity times height. Kinetic energy is the energy of motion, calculated as 1/2 mass times velocity squared. Energy constantly transforms, like on a roller coaster, where potential energy converts into kinetic energy. Section 3 is about power, which measures how quickly energy is transferred or transformed. Power equals work divided by time and is measured in watts. A sports car and a heavy truck may do the same work climbing a hill, but the car uses higher power because it does it faster. Momentum is the persistence of motion, calculated as mass times velocity. A large truck has much greater momentum than a small car moving at the same speed. Impulse, force times time, is the method used to change momentum. Airbags, for instance, extend the collision time to reduce the force. Conservation laws act as nature's accounting system. The conservation of energy states that total energy remains constant, only changing forms. The conservation of momentum states that total momentum remains constant in a closed system, exchanged but never lost. Collisions are classified based on kinetic energy conservation. In elastic collisions, like ideal pool balls, kinetic energy is conserved. In inelastic collisions, like car crashes, kinetic energy is lost, usually converted into heat or sound. Momentum, however, is always conserved in all collisions. These physics principles are at work every day. When braking, anti-lock brakes apply gradual impulse to reduce momentum. When throwing a ball, your arm does work, and impulse increases momentum. Even walking converts chemical energy into kinetic energy. Understanding energy and momentum is crucial in many fields. Car safety engineering uses impulse to design crumple zones. Sports science optimizes energy transfer for peak performance. These concepts also guide structural engineering and environmental policy decisions. Here is a quick reference guide to your physics toolkit. It summarizes the formulas and definitions for work, kinetic energy, potential energy, power, momentum, and impulse. Keep this handy for a quick review of the concepts. You now have the tools to understand the physics around you. Remember, physics is the hidden logic governing everything we do. Observe, analyze, and explore the world with new curiosity and confidence.